Hello, this is Mr. Buss. This video is intended to help you fill out the Lab 15 Solar Power worksheet for the lab that you just did. Alright, so you've already, hopefully before you did this lab, predicted your solar panel efficiency. I'm just going to put maybe 50% down as a prediction. Alright, make sure that your screenshots are all imported. Make sure to label the screenshots as to how far they were away from the light source, 20, 40, and 80 centimeters. All right, let's go ahead and work on the data and calculation section that some people are going to struggle with because some of these are a little bit tricky perhaps. So the first thing we're going to do is find the surface area of the solar panel. The previous video showed you how to do that. I just multiplied length times width. All right, so that's pretty easy. 5 centimeters times 10 centimeters equals 50 centimeters squared. Now we're going to convert centimeters squared to meters squared. Now I know that many of you are going to be able to convert centimeters to meters, no problem, but meters squared and centimeters squared is a whole different thing. So for example, I'm just going to go into, I'll just go into Google and I'll just show you that the conversion, centimeters squared to meters squared, is actually different. It's basically a 10,000 difference, and so 1 square centimeter equals 0.0001 square meter. All right, so if I've got 50 square centimeters, I have 0.005 square meters. All right, so I converted that to meters squared. Not difficult, just had to look that up. All right, next find power per square meter of solar panel. All right, so this might be tricky. So we're going to take our power output in watts. So let's find our power output in watts. All right, here's our power for the 20 centimeter distance in milliwatts, not watts. So we need to take 14.9 milliwatts equals, find out how many watts that equals. And not too tricky, but if I go milliwatts to watts, well, 1 milliwatt is 0.001 watts, so it's a 1,000 difference. All right, so that's pretty straightforward. I'm just going to move the decimal place 3 places, or I can simply use the conversion here. 14.9 milliwatts is 0.0149 watts. Oops. Oops, I'll just write 0.0149 watts. All right, now I got to take that and I divide by total area of solar cells in meters squared, which is right here. Okay, so I'm going to divide that by my 0.005 number. Okay, so 0.0149 divided by 0.005 meters squared. All right, 2.98. Watts per meter squared, and you can see those are my units in the calculation above. All right, next, the second to last row, looks like I'm going to try to find the available power. So the previous one is how much power in watts did I generate for the total area of solar cells. Now I need to know how much power was available. This really is pretty simple. I just need to take the light meter reading and divide it by 75. So it was the light meter reading. Looks like at the 20 centimeter distance my light meter reading was 2465 So 2465, and looks like I need to divide that by 75. That's what it's telling me to do. All right, 32.9 watts per meter squared. Excellent. All right, just one more row left. Find the solar panel efficiency. Okay, looks like here I'm going to take my power per square meter of solar panel. I've already calculated that, so I just need to write it again. 2.98 watts per meter squared. I'm going to divide that by the available power per square meter. So I take that, and I'm going to divide by that. So I'm going to divide by 32.9. Watts per meter squared. And in the end, I'm also going to multiply by 100 so that my answer comes out as a percent. 9.05. All right, so in the end, my solar panel was 9.05% efficient. So only 9% of the available light energy was actually being converted to electrical energy, as compared with my prediction of 50% efficient. And I'm going to calculate the 40 and 80 centimeter. Actually, I'm not going to do that because hopefully with the calculation I showed you at 20 centimeters, that's good. You just basically repeat the process using your numbers for the 40 and 80 centimeter distances. And when you're done with that, you can go ahead and answer questions here. All right, and then get your lab checked off by your instructor. Hope that helps. Have a great day.